Okay, so today we're going to talk about intercept form. So it's just another way to start the problem. Okay, so we have a P's and Q's, which honestly, there isn't like a great reason why we're using the letters P and Q. So don't worry about that. But the P and Q are the X-intercepts, where the graph crosses the X-axis. So it's another, X-intercepts is another way of saying the zeros, and we've talked about that a little while ago. Finding the zeros. It's because the y part of the coordinate has a 0. So that's another reason they say that. So, and so again, we got to look at the opposite. So just like in vertex form, we had minus h in the parentheses, and it was because of the minus we do opposite. So if and I'll come back to the a part in a second. So if this was the problem, the x-intercepts would be positive 2 and negative 3. So it's the opposites of what we see. Okay? So when we go to graph these, excuse me. Okay, so we actually get kind of from the very beginning of the problem, we get an advantage here. So I know that one point is positive 4, or excuse me, I didn't do the opposite. It's negative 4 because the x-intercept, or where the graph crosses the x-axis, and then instead of negative 2, it's positive 2. Okay, and so then again, when we do intercept form, I still want the axis of symmetry, and I still want the vertex. I need those two pieces of information. But there's two ways to think of the axis of symmetry in intercept form. I think a lot of people just say well, what's in the middle of these 2 points? So some of you, if you just count, it's got to be the same number of spaces in between. So if I count from this one, negative 4 on the left, if I count 1, 2, 3, I end up here in the middle. And if I count 1, 2, 3 from the other side, then there's the middle. And so the axis of symmetry is x equals negative 1, because it crosses the x-axis at negative 1. You could also, and this is in the book, but do p plus q divided by 2. So remember, the p's aren't they're the opposite of what you see. So if I did negative 4 plus 2, that's, excuse me, negative 2 divided by 2 is negative 1. So you get the same thing, but I think sometimes just saying what's right in the middle actually works better. Okay, and then the vertex is the same. We're just going to plug it in. So instead of x, I'm going to put -1. So -1 plus 4 is +3. -1 and -2 is -3. And sometimes these problems, we get these really big like numbers. So we get 6 and -3. So we get -18. Okay, so if that happens, like I'm gonna have to, let's adjust my graph a little bit. I'm gonna move everything up because I don't need to move the axis of symmetry up, but I am gonna move this one. So we had +2, -4, and then honestly, if you get a number like that, where it's like, I don't expect you to draw 18 lines, but remember the vertex is -1, -18. So we got to take the axis, and then what we get when we plug it in. So it's on the dotted line. It's on the axis of symmetry. It's way down here. That's -18. You can label it like that. I'm totally fine with that. Okay, and then in vertex form, I'm actually going to cut you guys a little bit of a break. We don't need to plug in the numbers because these points are far enough apart that we're going to have an accurate graph. The real reason to plug in two numbers is just to make your graph a little bit more accurate. But with vertex form, it's typically the intercepts are far enough apart that we don't need to worry about like that part of it. So we normally have step 1, what's the axis? Step 2, what's the vertex? Step 3, plug in two numbers and then flip them over. In intercept form, I'm fine if we don't plug in, the extra numbers. Okay, so it's going to ask you to graph the function. I did. Label the vertex. I did. Label the axis of symmetry. I did. And the x-intercepts. I did that. So then it's going to ask you again, what's the domain and range? And I think we talked about this a little bit anyway, but the domain for all these parabola graphs is always all real numbers. There's no way for me to design a problem that I couldn't plug in a number for x. It'll always work out. The range, on the other hand, is really, it's whatever the bottom or whatever the top of the graph is. So this one has a bottom, and the graph goes up. So it's greater than or equal to -18. Okay, so we talked about in a previous section that this is what's called a minimum point. And that's because that's as low as it's as low as it can go. The number that's the lowest possible when I plug in numbers is -18. If I choose different numbers for x, I'm going to get a number bigger than -18 every time. And I'm never going to get a number smaller than -18, like -19 or -20. Like that'll never happen. Okay? Unless you make a mistake, of course. Excuse me. All right. So you'll have your first few problems. Just going to say find the x-intercepts and the axis of symmetry of the graph, and it has like them graphed like for you. And then you'll have some that say graph the function, label the vertex, like I just said, axis of symmetry, x-intercepts, describe the domain and range, okay, which we just did. All right, and then your last set of problems, it's going to say kind of the same stuff, graph it, label the vertex, axis, and so on, except for it's going to look a little bit different at the beginning. It's not going to be in intercept form. You're going to have to make it in intercept form. So let's see, the first one, the first two, I think, yeah. So you're going to have to do some factoring, which we just did last chapter. So now I'm honestly okay if you just want to graph the problem. Like if this isn't in intercept form, it's in standard form. And if you just want to do, I'll show you both and then you can pick. So if you just wanted to say, okay, what's the axis of symmetry? And we say, oh, that's negative b over 2a. And you remember that stuff, and then you're like, oh, well, there's no b, so it's x equals 0. And then what's the vertex? Well, I plug it in, but if you remember, when there's no b, it's always going to be the number at the end. So I have 0, negative 4. And so there's the vertex. The axis goes right down through the middle. And then we're supposed to plug in numbers. So I'm going to plug in, not 0, I'm going to plug in 1 and 2. Because those are the two to the right. Okay, so 1 squared minus 4 is just 1 minus 4, or negative 3. 2 squared minus 4, 4 minus 4, or 0. So 1, negative 3, 2, 0. And then flip them over. And there's the graph. So that's not using intercept form. Okay, and it's just graphing it like we did, and this was in section 2. So for intercept form, you'd have to look at this and say, oh, I could factor this. Into x plus 2 and x minus 2. It's a difference of squares. And then you'd say, oh, here's my p and q. And it's kind of weird because, we're supposed to do the opposite, right? Well, the opposite of 2 is negative 2, and the opposite of negative 2 is positive 2, and those are the numbers we have anyway. But, you'd be able to say, okay, there's the intercept, and there's the intercept. And then what's in the middle? Okay, x equals 0. And then plug it in. So you're going to have to plug it into the, 0 squared is 0, 0 minus 4 is negative 4. And you have it. So I feel like either one, I think it's roughly the same amount of work, to be honest. So in this form, when there's no b in the middle, okay, so when we put a b in the middle, that's when I think being able to recognize that, hey, I could factor this is a big help. A couple problems like this, where it's a difference of squares factoring. And then, so if we had a problem like that, so if we were going to do the whole graphing with negative b over 2a, I got to do negative 8 over 2, a is 1, and then work it all out. And I think it's going to be a little bit longer of a problem, where if you can recognize that I can factor this, what times what is 12, that adds up to 8, 6, and 2. Now when I go to graph, my intercepts are, remember, they're opposite, so positive 2, positive 6, Okay, so there's my x-intercepts. The axis of symmetry is the middle. So the middle of 2 and 6 is 4. So x equals 4. Okay, and then I would need to plug it in to figure out the vertex. So I'd have 4 minus 6 and 4 minus 2. Negative 2 and positive 2 is negative 4. So the vertex is 4, negative 4. And then, like, honestly, as long as the 2 points are 2 spaces to the right or to the left of the axis of symmetry, I'm fine with you just drawing the graph. I will tell you that, and this is kind of a good piece of information, positive 12, so somewhere up here, is with the y-intercept. Because if I plug in 0 for the other stuff, I'm going to get 12. Okay, so you don't have to do the 12 thing, but I think intercept form is a lot easier, but you have to be able to recognize that I can factor that. So the domain, all real numbers. The range is y is greater than or equal to negative 4. Okay, so if you look at that bottom part, it's across from negative 4. Now, when it comes to these problems, I don't care, like if you look at it and you're not sure if it factors or not, then you can always just do negative b over 2a and then plug it in for the for the axis of symmetry, then plug it in for the vertex and pick 2 numbers to plug them in. It'll work. Okay, so you have options there. But I will tell you that you'll have a couple problems like this where it's just the regular kind of factoring. Okay, remember you got to factor something out first. So there's a couple of them where they have a number in common. So one of them has like a 48. You're going to be able to take out a number that makes that number quite a bit smaller. Okay. All right, so there's an introduction to intercept form. We'll do some more stuff tomorrow with it. But all right, hopefully you're doing good. Have a great day. We'll see you tomorrow.